What is an independent variable's role in a function's domain? Imagine you're setting up a simple machine where you decide what to put in, and it gives you a result. The input you choose is called the independent variable. In algebra, this is often represented by the letter x. The domain is all the possible inputs you can put into that machine without causing problems. Think of the domain as the list of all valid options for your input. The independent variable is free to take on any value within this list. For example, if your function is f, x is equal to 2x plus 3, then you can plug in any real number for x. The domain here is all real numbers because there are no restrictions. But if your function is f, x is equal to plus frac 1x2, then x cannot be 2 because that would make the denominator 0, which is undefined. So the domain excludes 2, and the independent variable can be any other real number. When graphing linear functions, the domain usually includes all real numbers unless you have a specific reason to limit it. For example, if you only want to look at positive inputs, you might restrict the domain to numbers greater than 0. The key idea is that the independent variable determines what inputs are allowed, and the domain is the set of all those inputs. Understanding this helps you see how the function behaves. If the domain is all real numbers, the graph stretches infinitely in both directions. If the domain is limited, the graph only covers a part of the line. The independent variable's role is to tell us what values we can use to get outputs from the function. It acts as the starting point for everything the function does. So, in simple terms, the independent variable is the input you choose, and the domain is the list of all the inputs that make sense for your function. Knowing this helps you understand where the function works and how to draw its graph accurately. It's like knowing the rules of a game before you start playing. The rules tell you which moves are allowed, and that's exactly what the domain does for a function.